Hello guys, welcome to Ramta Solutions. Welcome to your grade 11 mathematics, equations and inequalities exam prep. Today the question paper that we are looking at is the Gauteng provinces mathematics paper 1 of June 2024. Because this is an exam question paper, it's important that we read instructions. Remember, all the instructions are important, but I'm going to read just a few, not all of them. So, for example, instruction number 4, in fact, that says clearly show all calculations, diagrams, graphs, etc., which you have used in determining the answers. Then we have instruction number 5 that says answers only will not necessarily be awarded full marks. And then instruction number 7, if necessary, answers should be rounded off to 2 decimal places unless stated otherwise. Okay. Then, in as much as you want to get your level 7 or any distinction, let's put it like that, it's important that you improve your presentation. By that I mean improve your handwriting. Therefore, instruction number 10 says, write neatly and legibly. Okay? That is important. So guys, let's get to the questions. Now, note, this question is 35 marks. What does it mean? 35 marks means we should spend at most 35 minutes on this question. Okay? At most, we should spend 35 minutes on this question. However, if we cannot spend 35 minutes, don't take more than 5 extra minutes. Say, for example, 35, 40 at most. Okay, this is when it's a bit difficult. Okay, all right. But a tip is that if you find that you are spending more than 40 minutes in a question, you must move on to the next one. It means you are struggling with the question. Okay, all right. Cool. So now let's then head into it. Let's see what the first question is saying. The first question is asking us determine the value or values of x for which the expression square root of x squared plus 4 all over 9 minus x. So cool. 1.1.1, for which values of x will this expression be? Let's see, for which values of x will this expression have real values? For it to have real values, the denominator should not be 0. So we will say 9 minus x should be greater than 0. Okay, this therefore says 9 must be greater than x. Or in simple terms, x must be less than 9. Okay, x must be less than 9. Hope guys you heard what I said. I said here it means denominator should be greater than 0. Okay. 1.1.2, determine the values of x for which this expression is not defined. For it to not be defined, this value here, the denominator must be equal to 0. So 9 minus x should be 0. So we can say x is equal to 9, isn't it? For those that might be finding this confusing, it's similar to me saying x equals minus 9, x equals 9. Okay. However, it's not really necessary. So it's fine if I say x equals 9. Okay. Cool. 1.1.3 rather. 1.1.3 says given x equals 1, is the expression rational or irrational? So they said x equals 1. So let's see. This is 1 square minus 4, plus 4 over 9 minus x. Of course, the square root of it. So what is this? You guys have calculators. this will be 5 over, oh boy, what did I do now? This is supposed to be 1, huh? So this is 5 over 8. So square root of 5 over 8. Therefore, it is irrational. All right? It is irrational because you cannot write this thing in a fraction, right? It will be recurring. So, will it be recurring? No, it's non-recurring. It'll just be a decimal that you cannot represent in a fraction, right? So it is therefore irrational. Now, 1.1, 1.1.4, determine the value or values of x where the expression will yield a recurring decimal value. So for it to have a recurring decimal value, I want to think of x equals 0. So let's try x equals 0. When x is equal to 0, you will be having 0 squared. Okay, let me write it in a red pen. 0 squared plus 4 over 9 minus 0. This will then be 2 over 3. You do know that this is 0 comma 6. Is it 666 or 6777? I think it's 0 comma 6666666666666. Right? So this number is recurring. Right? Okay. So now moving on. We then need um 1.2. Oh boy. 1.2, what do we do? 1.2 says 1.2, oops, let me change the color. 1.2 says, remember guys, we should spend 35 minutes in this question. 1.2 says, given 2x squared minus 3x minus k equals 0, determine x if 1.2.1, k is 5. So we'll say 2x squared minus 3x minus 5 equals 0. So this is 2x minus, let's see, 2x minus 5, and then x minus. So the constant here, the constant is negative. So it means the bigger factor must have the sign of the middle term. The middle term is negative. So this one must be positive. Okay. Then we say x equals 5 over 2 or x equals negative 1. Guys, if you struggle to factorize this, please use your quadratic formula. Okay? Please use your quadratic formula. 1.2.2, and for those that are using this newest Casio calculator, for example, FX991ZA, it'll help you with your equation as well. Okay? Cool. Now, here, k is equal to 4. Now, correct to 2 decimal places. So, we will say 2x squared minus 3x minus 4 is equal to 0. So, yes, we must use a quadratic formula. If you don't remember your quadratic formula, you can check it out at the back of your question paper, or it is given in the information sheet. Okay, it is given in the information sheet. Okay, so here x equals negative, what is the value of b? Negative 3. We said the value of b is negative 3. What is the value of a? It is 2. The value of c is negative 4. Right? Negative 4 all over 2 times 2. Okay. All right. Now, let's go. Simplifying, x equals negative times negative. This is positive, so it'll be positive 3 plus 4 times 2 is 8. And then 8 times 4 is 32. 32. Right, it's 32. Cool. And then 3 squared is 9. So 9 plus 32 will be 41. So this becomes the square root of 41 all over 4. Now proceeding, we say 3 plus square root of 41 over 4. What do we get? We get x equals, 2,35. Or, now let's change. At 3 minus square root of 41 all over 4, we get x equals negative 0.85. So remember, guys, we want to make sure that we are done in 35 minutes. Okay? All right. But of course, we will try to explain where we need to explain, because, of course, the reason you are watching this video is to see how we attempt such questions, right? Cool. Now, we are done. Let's proceed to 1.3. 1.3 says solve for x 1.3.1 when you have x minus 4 equals minus x minus 2. Remember this one here. As you can see, you have the highest power is the highest power is 1. So it means possibly you might have more than one root or one solution, but only one is valid. So let's see, for example, I will square both sides. Let me square both sides. It'll then be x squared minus 8x plus 16 equals negative times negative is positive. Then we have x minus 2. Proceeding, we have x squared minus 9x plus 18 equals 0. Okay? Now we say x minus factors of 16 or product of factors of 16. 9 and 2 will not work. I will try 6 and 3. 6 and 3 indeed, because both are c is constant. C is positive, which is 18. Both factors must take the sign of the middle term. So indeed, 6 and 3 will work. So we have x equals 6 or x equals 3. All right, x equals 6 or x equals 3. Let me start with the lowest number, 3. Let's see. Or let me take 6 as it is. 6 minus 4 is 2. So the left-hand side is positive 2. The right-hand side, 6 minus 2 will be 4. Square root of 4 is 2. However, it doesn't end there. You have a negative here. So you will be having 2 is equal to negative 2. Therefore, this one doesn't work. The one that's working is x equals 3. Happy? All right. Okay. Now, having said that, we can proceed now. Let's see. Now we're going to 1.3.2. 1.3.2 says x squared plus 4 is greater than 3x plus 2. Right? Is greater than 3x plus 2. So in standard form, x squared minus 3x plus 2 is greater than 0. Product of factors of 2 are 1 and 2. So let's see. Constant is positive. As you can see, the 2 is positive. So both vectors must take the sign of the middle term. So we are good. Critical values. Of course, this is when x is equal to 1 and x is equal to 2. Happy? This is when x is equal to 1 and x equals to 2. Happy? Great. As you can see here, this is a parabola that is smiling. Remember that instruction that says show all diagrams, calculations, and so on that you have used in determining your answers. This is what they meant. Okay. So for it to be positive, we are saying which values of x will this graph be above the x-axis. This is what they mean when they say greater than 0. But this line here represents the x-axis. So which values are those? Is when x is less than 1 or when x is greater than 2. Happy? Great stuff. This is how you interpret it. Okay, guys? Hey, Tara. So let's see. This question, you're supposed to have done it in, let's see, 14, 18 minutes. And we did it in 15. Minus the 3 minutes, it's in 12 minutes. Okay. Now let's see. 1.4. 1.4, we have 2x equals y plus 2. We will label it equation 1. And then we have 2x squared equals 2 minus y squared. We will label it equation 2. So one that's easy to manipulate is equation 1. So we'll say y equals 2x minus 2. We will label it equation 3. I like saying from equation 1. Okay, so the one that you didn't use, or the one that you didn't use to make equation 3, you need to substitute into it. Therefore, in other words, I'm saying on equation 2, where there's y, you will put 2x minus 2. Maybe let me write that instruction. Substituting equation 3 into equation 2. Okay? All right. Then we have 2x squared equals 2 minus, open bracket, 2x minus 2 all square. Remember what I said? Where there's y, you will put equation 3. All right. So we have 2x squared equals 2 minus, this becomes 4x minus 4x squared minus 8x plus 4, right? Plus 4. Further simplification. Minus 4x squared plus 8x minus 4. Okay, now collecting like terms, we have 6x squared minus 8. Is that so? 6x squared, is it minus? Yeah, it is minus. Yeah, it is minus. So minus 8x. 2 minus 4 is minus 2. Coming to the other side, it will be positive 2 equals 0. Now dividing throughout by 2, this then becomes 2x squared, 3x squared rather, minus 4x plus 1 equals 0. Is this easy to factorize? I think so. Therefore, 3x. Oh my, oh my. Oh my, oh my, oh my. Come on, buddy. Okay, so this is easy to factorize. Now we will say this becomes, this becomes 3x minus, let me see, this becomes 3x minus 1, of course, and then x minus 1. So let's see, the constant is positive 1. It means the both vectors will take the sign of the middle term. The middle term is negative, so both are negatives. Okay, so this is it. We can proceed from here. Now this says x equals 1 over 3 or x equals 1. Okay, so let me just write this instruction here. Substituting the values into equation 3. substituting these values into equation 3. Guys, this I am only writing it in order for you rather to understand, but it's not necessary. Okay, same applies to the instruction here. It's not necessary. Okay, let's proceed. We had said y is 2x minus 2. So if y is 2x minus 2, this will then mean y is 2x minus 2. So it'll be 2 over 3 minus 2. It must be minus 4 over 3. Minus 4 over 3. And here, again, x was 2x minus 2. So it will be 2 times 1 is 2. Minus 2, it's 0. So y is 0, not x, man. So y is 0. Okay? Another y is 0. Okay? And this is how you solve this. This is how you solve this problem. Okay? All right. All right. Moving on. We go into question 1.5. It says we have 2x squared minus 2x squared plus 4x minus 3 equals negative p. Okay, let's see what 1.5 says. 1.5 says, for which values of p will this have two unequal roots? For it to have two unequal roots, these are nature of roots. So you must write it in the form ax squared plus bx plus c is equal to 0. Therefore, it will be minus 2x squared plus 4x minus 3 plus p is equal to 0. Your discriminant, which is b squared minus 4ac, must be greater than 0. Okay, what is the value of b? It is 4. What is the value of a? It is negative 2. What is the value of c? It is negative 3 plus p. Close, all these greater than 0. This is 16. 4 times 2 is negative 4 times negative 2 is negative 8. Negative 8. No, it's positive 8. Positive 8 times negative 3, it's negative 24. Negative 4 times negative 2, we said it's positive 8 times p, it will be plus 8p. This is greater than 0. 16 minus 24 is 8. Negative 8, by the way, isn't it? Therefore, 8p is greater than 8. We can simply say p is greater than 1. P is greater than 1. Okay, perfect. Now, 1.4, 1.5.2 now says, for which values of p will this have two positive roots? All right. So remember, we said this is, what was it? It was minus 2x squared plus 4x minus 3 plus p equals 0. Now, what if we say, remember, originally it was minus 2, it was minus 2x squared plus 4x minus 3 equals negative p. Let's call this one f. So f of x equals negative p. Okay, so for now, I want us to focus on this was the original f. But now, to have positive roots, okay, to have positive roots, to have two positive roots, I want us to note this. We will say 1. Remember, we have 2x, negative 2x squared plus 4x minus 3 plus b. All right, so here, a, we can see that it is negative. All right, now if a is negative, we can also see that b is positive. Right, now if b is positive, what should happen with the value of what should happen with the value of b? What should happen with the value of b for this to have two positive roots? The value of c should also be negative. Okay, the value of c should also be negative. Please note, this is just a reminder to myself, right? So to have two positive roots, a must be negative. As is the case, it's negative. B is positive, you can see it. Therefore, the constant must also be negative. Okay, so with that, we can say, okay, this therefore means C, you remember, I said C must be negative. What is C? C is negative 3 plus P, all right? C is negative P plus 3. We said it must be less than 0. Therefore, P is less than 3. But hold on. Hold on. If you say P is less than 3, yes, you're saying you will get two positive roots. Now, you did say as well that you will also have um at P, which one? At P is greater than 1, you will have two unequal roots. You are avoiding a situation where you have repeating roots. All right. You are avoiding a situation where you will have repeating roots. So rather say, okay, P must be greater than that one that we calculated at 1.5.1, or must be less than 3. So P must be greater than 1, but less than 3. So here is where we leave this question. Okay. Alternatively, method 2, okay, method 2, I want to say 2, not really going to show it. Method 2, draw this one. Draw minus the one given here, minus 2x squared plus 4x minus 3. Okay, when you draw it, you will realize that it is something like this. You will realize that it is something like this. Okay, as you can see, y-intercept is negative 3, and then it'll be like this. Turning point will be, what is this? This is positive 1, and this one here will be, is it, is it'll be negative 1. Okay, it'll be negative 1. So turning point will be 1 and negative 1. Okay, turning point will be 1 and negative 1. So for it to have two positive roots, check this out. If you move this graph 1 unit up, if you move it 1 unit up, you will have repeating roots, meaning the axis of symmetry is also the turning point. That's why we're calling it repeating roots. That's not what you're looking for. You said both positive. So try to move it. If you move it now, if you can see, this is your y-axis. If you move it 3 places high or 3 places up, the y-axis will then be at 0. That will not be two positive roots. It will be one positive root. So try to move it where? You must then try to move it. You must then try to move it how? 1 unit up. That's okay. At least 1 unit up is okay. But then less than 3 units up. So if you try to move it more than 1 unit up, but less than 3 units up, you will be okay. All right. Think about it. If you move it 2 units up, if you move it 2 units up, it will be somewhere here. So y-intercept will be here. Do you see that? If you move it 2 units up, it will be here. If you move it 3, oops, this is not what we want. Do you guys see it? So it is like this. Okay? You can also show this in this manner. Okay? Hey, tada. All right. Now let's see. 1.6, show that the equation p squared plus 1 close times x squared equals minus 2p qx minus q squared has no real roots for p and q. For p, rather, has no real roots for p, and q is an element of real numbers, and q is not equal to 0. Okay, it is still nature of roots. So in standard form, p squared plus 1 close times x squared plus 2pqx plus q squared equals 0. So they say we must show that it has no real roots. So we'll say b squared minus 4ac. What is b? B is 2pq. What is a? A is p squared plus 1. What is q? What is c? C is q squared. So let's see now. 2pq times itself will be 4p squared q squared. Okay. Now 4 times pq, if you like, maybe let me just do it like this. It'll be, okay, no, it's fine. This will be 4q squared times 4p squared times q squared, all right, minus 4 times 1 is minus 4 times q will be minus 4q squared. As you can see, 4p squared q squared are cancelling. We are left with minus 4q squared, isn't it? Cool. So now what we are seeing is this. Remember, they said show that it has no real roots for p. Indeed, there is no p here. Therefore, it has no real roots for p because p is not defined here. All right? And again, if your discriminant, remember, for you to say you have no real roots, the discriminant must be less than 0. All right? And the discriminant must be less than 0. All right? And it has no real roots for p and q is an element of real numbers, right? And q is an element of real numbers. However, q is not equal to 0. So any q value you can think of, okay guys, any q value you can think of except 0, you will always have your discriminant being negative. When the discriminant is negative, it means you have no real roots. This is when you say you have non-real roots, isn't it? When your discriminant is negative, you have non-real roots, right? So if your q is 0, your discriminant will be real, right? It'll be real, and to be precise, it'll be real, and you will have equal roots. This is why we say q is not equal to 0. Okay, so this is it, guys. We have come to the end of our lesson. And remember, if you would like to get in touch with us, visit our website www.ramtasolutions.co.za. Remember as well to follow us on your favorite social media platforms. And the links to the different social media platforms are given in the description of this video. You can also check us out on WhatsApp. So with that being said, it's a wrap and bye-bye.